Throughout this training, or at any time you need support, there are many ways to contact us. You can follow us on all major social media platforms or email us directly via our website, or you can click the Cancel Connect icon shown at the bottom of this slide on our website to book a consultation with one of our experts.
So Claire, what are we talking about with our next chapter?
We are talking about load leveling, also
Load leveling?
called Haijunka.
Haijunka.
What is it about? Business owners, managers, and employees are usually painfully aware, I'm sure you are, how difficult it can be to maintain a stable flow of work. Haijunka is a lean method for reducing the unevenness in process and minimizing the chance of having more work than we can handle, or not enough work to keep us productive. The term Haijunka is a Japanese term that means leveling, and it can help us to react to demand changes and utilize our capacity in the best possible way.
Please be aware that these Japanese terms are not always something you need to remember, but do remember, that it does mean load leveling. So in North America, Haijunka is more commonly referred to as load leveling, as I just said, and it refers to the balanced volume or workload within a process. Balancing a process reduces the non-value added portion of the process and removes the waste of items waiting in queue so that we can efficiently meet customer demands while avoiding unnecessary costs and time.
So you can follow along with the charts in your workbook for this next example. Let's say that a hat maker receives orders for 500 of the same hat every week. They get 200 orders on Monday, 100 on Tuesday, 50 on Wednesday, 100 on Thursday, and 50 on Friday. So instead of trying to meet demand in sequence of the orders, the hat producer would use Haijunka to level demand by producing an inventory of 100 hats near shipping to full Monday's orders. Every Monday, 100 hats will be in inventory. The rest of the week, production will make 100 hats per day, a level amount. By significantly reducing waste and the excess of physical inventories that can result when we don't have level loading, a company can improve its cash flow and lower its costs. Consider the fact that when work goes uncompleted, it cannot produce revenue. Now, let's talk about the concept of batching.
Imagine that you work in a busy high-rise building in the city and you are trying to get to your office quickly. You have an option to take the elevator or the escalator. If you choose the escalator, you step right on it and it takes you directly to your desired floor. Each individual gets on and off when they are ready, one at a time. If you choose the elevator, you wait outside the elevator, usually waiting as more people accumulate, until the elevator door opens. The group or batch of people get on the elevator together. You may have to stop at multiple floors before getting to your destination. There are advantages and disadvantages to each option, and that's our topic for this section. What's the right solution for your process to increase flow and to minimize or eliminate wastes?
Most companies, especially manufacturing ones, resort to a batch approach thinking that it's a cost-effective solution. Batching is popular because there are minimal costs due to changeovers, and there's prepared stock to meet customer demand. But these assumed benefits can actually do your company more harm than good. When you batch your production, you can experience some significant issues, such as
the inability to respond to changing customer demand. No matter how many forecasts we produce, it is very hard to predict and be certain of customer demand. There will always be fluctuations and variations. If we consistently produce in batches, we may lose the opportunity to provide the customer with a product that they actually want, simply because we are not producing it at that specific time.
Another issue might be capital being tied to inventory. Because companies want to make sure they have enough stock to provide to customers, they produce large quantities. But these effectively get stored as inventory and don't make the company any money until it actually gets sold. There can be instances where the company needs to sell the products just to free it up. There's certainly not ideal terms for
profitability.
Thank you.
We all like these massive warehouses, but at the end of the day, all you see is losses. Okay, the third one is overworked machines and personnel. I'm sure you guys know a few of these. Producing in large quantities every time can eventually lead to machine and staff breakdowns, like physically and mentally. This can also affect the quality of your final goods, which can lead to more waste and more rework. These are the main problems that Heijunka aims to solve. Heijunka allows companies to produce as close as possible to what demand dictates. This is done by producing smaller batches and creating different types of product at one time. Companies can be more flexible to demand changes, minimize inventory, and balance out the use of its resources with this approach.
A Heijunka box is a scheduling tool used to visualize the work items that need to be completed to meet the average customer demand. Basically, it's a system that visualizes each product's orders, and according to the average demand, it levels a production sequence for achieving an optimal flow.
Take examples of a textile firm struggling to keep up production with the demands. If customer demands of a garment is 15 pieces on one day and then the demand fluctuates by 3 or 4 pieces per day, the company can use a Junka method to control this variation. They can set the level volume at 15 garments per day according to the demand. Production would replenish the 15 garments that are ordered. On the second day, if the order of 19 garments, 4 garments higher than levelized production volume, the company would still produce the 15 garments and the shipping area would take 4 garments from an inventory known as fluctuation stock. On the third day, if the order will be 13 garments, which is 2 less than a Junka volume, 2 garments can be rebuilt and put back into fluctuation stock. This is a very basic idea of how the concept works.
The Heijunka method of manufacturing can be deceptively simple, but pretty complex when it's fully realized. It starts by measuring the takt time. That's the time it takes to manufacture a specific product, ship it, and get it into the hands of the customer. It's the rate at which the customers buy a product. Once you know the takt time for every product your company creates, the next step is easy. Work slowly.
I know it sounds counterintuitive to what you've been told, but load leveling really works. Each week, take your time and manufacture only enough product to cover demand and takt time once you've measured it. If there's a surge in customer demand, simply manufacture more of the product over the next week. If you keep a small amount of safety stock, this approach keeps the manufacturing patterns predictable, stable, and still flexible, which is exactly what we are aiming for.
So while Heijunka is not exactly rocket science, applying it to real-life production situations can be more complex than we can imagine. It may take a while before you actually get a hang of things. It's important to stay attuned to customer demand and adjust your process as you need to. It should also be the company's priority to continuously improve and optimize their operations so that a more leveled workflow is established.
So please be aware, you're going to try all these things and you might not get it right the first time. But please keep trying. That's how continuous improvement works. And applying Heijunka can be a trial and error situation. Don't expect to nail it the first time. But once the company has it in place, they can be sure to reap the benefits of a more standardized flow of production.
So we mentioned takt time. It's a key factor to understand when working to load level. It's the calculated pace required for production based upon the average speed at which the customer is buying a product or service. The formula is the net available time to produce per time period divided by the customer demand per time period. So follow this calculation in your workbook. If the net available time is 450 minutes per shift and the customer demand is 150 pieces per shift, then the takt time is 3 minutes per piece. That means that in order for us to keep up with the demand, we need the cycle time to produce a single piece to be 3 minutes or less.
So takt time isn't a measure, it's a calculation. A lot of places get this wrong when they do visual performance management. It's not the time it takes to perform a task, and it's only reduced or increased by changes in the factors, the production demand or net available time to work. Takt is a German word for beat or rhythm, and is often likened to an orchestra conductor keeping time.
Another concept under the topic of load leveling is single piece flow. Fundamentally speaking, all aspects of Lean Six Sigma aim to reduce or ultimately eliminate waste, which we understand comes in various forms. One piece flow is typically implemented to minimize waste between steps or processes, specifically inventory or work in progress and inactivity. The idea is for a unit in the process to be pulled through each step efficiently.
Batch processing, also called batch and queue, is a mass production approach to operations in which large groups or batches of items are processed and moved to the next step. Whether wait in a pile or a queue until the next worker is ready to perform the next step. If there were 3 of us working together to send out 1,000 invitations, we might have the following steps. Number 1, put the invitation in the envelope. Number 2, seal and stamp the envelope. And number 3, write the address on the envelope. In a batch process, person A would stuff the envelopes, and when he has a batch done, let's say 100 invitations, he'd put that pile in the inbox of person B. Then person B would seal and stamp 100 envelopes and put that pile in the inbox of person C. When person C is ready, she would address each envelope. That's batch processing.
One piece flow is producing and moving one item at a time, or a small and consistent batch of items, through a series of processing steps as continuously as possible, with each step making just what's requested by the next step. It's also called one piece flow, single piece flow, and make one move one. In our invitation example, each person would complete their step and move the unit directly to the next station. The skill is making sure that each step can keep up the pace so that the unit flows continuously without waiting. So what's the right batch amount? How many people do we need at each step? How do we create a process that flows?
Many years ago, efficiency experts realized that batching had some serious drawbacks, such as customer demand is hard to predict. If a buying trend inspires a consumer frenzy over white widgets, the company will need to adjust their process and drastically increase white widget manufacturing, which in turn takes away from the black widget manufacturing.
Another issue might be unsold goods that don't make any money. If the company overproduced white widgets, they need to either throw them away or store them as unsold inventory. That's wasted effort and inefficiency.
Machines and personnel get overworked so easily. A change in process requires a lot of startup and slowdown time, which can create inconsistent product quality and exhausted equipment and people. These efficiency experts recognized the drawbacks of batching and believed we could improve the efficiency if we could just get everyone to slow down. The famous analogy associated with the single piece flow is the story of the tortoise and the hare. The slower but consistent tortoise causes less waste and is much more desirable than the speedy hare that races ahead and then stops occasionally to doze.
Let's talk about batch processing in the digital workspace. Batch processing is an efficient way of processing large volumes of data. With batch processing, data is collected, entered, and then processed. Afterward, it produces batch results, like payroll and billing systems. Those are beautiful examples of batch processing. Batching means waiting to do everything all at once. Also, it means relying on the ability of your system to handle it all.
And we're not saying it's right or wrong. We're just teaching you the basic concepts, yeah? So batch processing is ideal for processing large volumes of data or transactions. It also increases efficiency rather than processing each individually. With batch processing, we can do the heavy system processing independently, even during less busy times or at a desired designated time. That said, there may be a time delay between the collection of data and completing the process for the whole batch. In the batch processing, the master file is not always kept up to date because of the time delay. And this time delay can be significant if the process time for a large batch is very slow.
Real-time processing involves continuous input, continuous processing and output of data, so it processes data or transactions in a short period of time. Some examples of real-time digital processing would be like bank ATMs, fraud detection, any point-of-sale systems, In these scenarios, every single transaction is immediately processed and updated in the master file, so it's always up to date. Real-time processing is best for processing or computing something relatively simple. When we need to compute in near real time, only seconds at most, we go for real-time processing. While performing real-time processing, there's no significant delay in response.
In real-time processing, because information is always up to date, it makes the organization able to take immediate action and respond to an event, issue, or scenario in the shortest possible time and be very flexible. It also allows the organization to gain insights and to detect patterns from the real-time data. The disadvantages are that real-time processing is very complex and it can be a more expensive option. Why one-piece flow won't work? Rather than insisting that one-piece flow will work, we like to ask people why one-piece flow will not work for them. Here are some of the most common reasons we hear and some ways we respond, Claire.
Yep. The first reason that we hear is that we can't get the needed materials in the quantity, in the quality, or in the time we need, or we have unreliable equipment that maybe breaks down, causing downstream processes to run out of parts or information. You're absolutely right. Fix these issues first.
You have to.
If you can't get the support to address these issues, you might need to do some calculations to make a case to leadership for why one-piece flow would help your process.
Number 3, our people will resist this change. We hear that all the time. Okay, we already know that. That's what stakeholder management and communication is for. If the leaders don't understand and believe in one-piece flow enough to take the time to support the effort and to help with stakeholders, please don't even bother with this one.
Number 4, our people are not cross-trained to do more than 1 or 2 limited tasks. Sounds like one of the 8 wastes, huh? Underutilized talent. In this case, we've limited people's potential to learn and develop to their fullest. Take boring out of the workplace by giving people variety, and you'll actually see morale improve. People aren't motivated to learn new things, you say? Then let's go back to the answer on item number 3. Sounds like a stakeholder management issue.
Number 5 is long changeover times prevent us from doing one-piece flow. This is another situation where you'll need to fix that situation first. When changeovers present a genuine barrier to one-piece flow, reduce the changeover time continuously, all the while reducing batch sizes to approach the one-piece flow.
And number 6 is that there's too much distance between processes to move one at a time. Too much distance. I'm thinking that by this time, with everything that you've learned so far, this is one that you can figure out all on your own.
What do we do with distance? Okay, number 7. The process produces defects that will stop the line too frequently if we have no buffer. Another problem that needs to be addressed first. Before you can implement one-piece flow, figure out why there's so many defects.
Number 8, process cycle times are unstable or too variable, creating an imbalance between workers. This requires an understanding and a reducing of variation, again, before we try to implement one-piece flow.
Number 9, our machines are not designed for one-piece flow. This is too true, even in our daily lives. A washing machine is a good example. Need to wash one shirt? You have to wait until you are close to a full load, or you waste water and energy. So we batch our dirty clothes. The same is true with a dryer. You don't dry one wet shirt in the machine at a time, but you might hang it up to dry if you don't need it to dry right away. Equipment can be a real constraint, but it might be worth brainstorming some creative solutions if it makes sense for your project.
And lastly, we have occasional work that interrupts the process. Here we'll introduce a new role called a water spider. This is a role centered around timely and accurately handling tasks. The water spider as a team member is much like a mobile Kanban system that supports production to maintain a steady flow. The water spider term comes from an insect by the same name. They appear to be able to hang between the water and the air while quickly going from place to place, keeping both of the environments in their sight simultaneously. How a water spider moves about the process and the way they perceive all the process steps at once resembles the beetle's movements and sight, giving the role its name.
If the root cause of your problem can be minimized or eliminated by improving the workflow or load leveling, you can explore multiple options, including the topics that we've covered in this section: batch versus single piece flow, Heijunka, designing your process to match the takt time, and determining how this applies physically and digitally, because it does. Most processes have a combination of both. Making a decision of selecting the best method depends on the specific scenario. This one-point lesson on load leveling provides a high-level summary of each of these techniques. We've completed the section on load leveling. Now just move on and test your knowledge on it. It has been our sincere pleasure being with you through this part of the training, and we thank you for your dedication to creating a better workplace and an environment that you can truly enjoy.